Assalamualaikum. Nama saya NOOR ADRIEANA binti HADI, Matrik CV 190084, dan kawan saya
Wan NASIHAH binti SHAHIDAN. Matrik saya CV 190090.
Okay, hari ini kita orang akan bentangkan chapter 3 Ventilation System.
3.7 Fan Law. 3 basic fan law. First, volume of air flow. Volume of air flow, what happened to the flow rate if the impeller speed change. Second, pressure, what happened to system pressure if the air volume rate change. 3, power, what happened to the power demand if the impeller speed change. Okay, for the first fan law, volume of air, the volume of air moved by a fan change in direct proportion to the change in speed of the fan impeller can be calculated as follows. These are the formula. V2 equal U2 per U1 times V1. For V2 is volume of air moved meter cube. U2 is air produced. U1 is speed. V1 potential reduction in speed. This is a useful relationship as it allows us to use change in volume when calculating the other fan law. This is for the example for volume of airflow. For example, a fan produces 1000 meter cube per H at an impeller speed at 2000 RPM. What is the resulting airflow if the speed was reduced to 1000 RPM? For example, V2, 1000 of a fan produced as at an impeller divide by 2000 RPM times 1000 is equal 500 meters square per H. The second fan law, pressure. The pressure developed by the fan and the pressure drop in the system varies with the square of the change of speed of the impeller or volume passing through the system. These are the formula. P2 equal U2 per U1 per square times P1. P2 is change in the pressure, U2 change in speed, U1 speed, P1 is pressure. This is the example for the pressure. The question is a fan produces 2000 PA at an impeller speed of 1000 RPM. What is the change in the pressure if the impeller speed was increased to 2000 RPM? This example, P2 equal 2000 per 1000 square times 200 of pressure at an impeller speed equal to 800 PA. The third fan law is power. The power required to move air through the fan or system varies with the cube of change in the volume and is calculated as follows. This is the formula. W2 equal V2 divide V1 cube times W1. W2 is new power input in watt. V2 is power input in watt. V1 is volume of air in meters cube per H. W1 is change in or new airflow meter square per H. Interestingly, is noise generated by the fan is also a power relationship and again varies with the cube of the change in air volume handled. For the example for power, the question is if the power input to the impeller is 500 watt delivering a volume of 1000 meter per H, what is the power input when the same impeller is delivering 500 meters square per H? For example, W2 equal 500 divide 1000 cube times 500 equal is 62.5 watts. This is the fan law summary. Fan law are essentially about impeller and what happened to their characteristic when they undergo change in rational speed, air density, or air scale in size. 3.8 Sound attenuation in ductwork. For definition, sound attenuator are prevent and effective method for reducing the noise generated by fan and other equipment. Also referred to as duct, silencers, sound trap, and mufflers. They are designed to reduce the noise transmitted from a source to the receiver. Type of noise control. First, acoustical lower. 2. Grill silencers. 3rd, rectangular elbow. 4th, rectangular silencers. 5th, sound check panel. 6th, transfer silencers. 7, tubular silencer. For acoustical lower, primary application for cooling tower, mechanical room, tunnel ventilation, parking garage ventilation, and general ventilation. For the characteristic, first, acoustical attenuation across all 8 octave bands. Second, good water penetration performance. Third, may be provided with a number of variations such as filter rack, security bar, and insert and bird screens. Next, grill silencers. For primary application, no ducted return grills, vertical package, AHU return or supply grill, retrofit application, general ventilation, portable generator set. For characteristic, broadband acoustical performance and 4-inch depths. Next, rectangular elbow. Primary application, rooftop AHU supply and return duct system lacking, sufficient straight duct run. For characteristic, compact design, excellent broadband performance, wide variety of configuration, acoustically transparent perforate liner, and acoustical grade fibrous media. Fourth, rectangular silencers. For primary application, rooftop AHU supply and return duct system lacking, sufficient straight duct run, and for characteristic, stacked into large bank, thus accommodating an infinite amount of duct size, eliminating expensive transitions, length between 36 inches and 120 inches. For sound check panel, primary application, planar, enclosure, and barrier wall application. Characteristic, the panel can be designed to fit in practically every situation requiring enclosure silencing. For transfer silencers, primary application is non-ducted return plenum, hotel restroom as house, retrofit application, general ventilation. For characteristic, broadband acoustical performance configuration for all application. For transfer silencers, primary application, standard, round ducted or non-ducted axial fan, tunnel ventilation, parking garage ventilation, fan tower, and general ventilation. For fibrous liner, clean room, system, hospital, chemical, laboratories, fume house. For characteristic, acoustical attenuation cross along all 8 octave bands, size to match fan dimension, enhance fan performance. 3.9 Air filters. For definition, air filtration captures air particles at the source through specialized filters or carbon gas filters and release clean air back into the environment. One main distinction between filtration and ventilation is that air filtration doesn't bring in the needed fresh air, oxygen, to a building. Ventilation does that. Type of air cleaners and purifiers. First, air cleaner. 2. Ionizer and ozone filter. 3. Allostatic filter. 4. Activate carbon filter. The last is UV light. First, the air cleaner. The most common type of filter is made of foam, fiberglass, cotton, or another particle trapping material. You have to change the filter every month or 2 once they fill up with particulate. To determine the strength of your air filter, check the MERV rating. The higher the MERV rating, the better the filter. Next, ionizer and ozone generators. One difference between them is that the ionizer operates during a control time, since this device usually have timer while the ionizer continually produce ion. Ozone generator produce ozone as the main product while ionizer produce ion. Third, allostatic filter. Air Commander allostatic air filter clean the air by using static electricity, a safe, naturally occurring phenomenon. Fourth, activate carbon filter. Carbon air filter are the filter most commonly used to remove gases. They are also often used to remove odor from the air, such as the smell of tobacco smoke. The lastly is UV light. UV light is part of the electromagnetic spectrum, which make up all wavelength of electromagnetic radiation, including light, radio wave, and X-ray, which are arranged according to frequency and wavelength.
Okay. For 3.10, low velocity air flow in ducts. Simple duct air system, typical of those serving internal WCS and bathroom, operate at relatively low air velocity with little frictional resistance or pressure drop. In this situation, the relationship between airflow and duct diameter can be expressed as, this is the formula, Q equal to airflow rate in meter cube per second, D duct diameter in millimeter, has pressure drop in millimeter water, and length of duct in meter. To determine duct diameter from this input data, the formula is respected like this. For velocity classification, ducts are classified into 3 basic categories. First, low velocity system. They are characterized by air velocities up to 2000 fpm. Second, medium velocity system. They are characterized by air velocities in the range of 2000 to 2500 fpm. Third, high velocity system. They are characterized by air velocities greater than 2500 fpm. The low velocity system is used in most air conditioning installation because it is quieter, has low friction losses, lower fan power, and lower air leakage. High duct velocity result in low internal cost but required increased fan static pressure, therefore resulting in increased operating cost. noise attention, use of noise silencers, and are not suitable for comfort application. For pressure classification, duct systems are also divided into 3 pressure classification, matching the way supply fans are classified. First, low pressure. The term low pressure applies to systems which fan static pressures less than 3 inches WC. Generally, duct velocity are less than 1500 fpm. Second, medium pressure. The term medium pressure applies to system with fan static pressure between 3 to 6 inches WC. Generally, duct velocities are less than or equal to 2500 fpm. And last, high pressure. The term high pressure applies to system with fan static pressure between 6 to 10 inches WC. Usually, the static pressure is limited to a maximum of 7 inches WC, and duct velocity are limited to 4000 fpm. System requiring pressure more than 7 inches WC are normally unwearable and could result in very high operating costs. Okay, for 3.11, air diffusion. What is air diffusion? A diffuser is a device for reducing the velocity and increasing the static pressure of a fluid passing through a system. The fluid static pressure rises as it passes through a duct is commonly referred to a pressure recovery. In contrast, a nozzle is often intended to increase the discharge velocity and lower pressure while directing the flow in one particular direction. The system designer will select the most appropriate type of diffuser for the space, taking into account the following points. First, use of space and required aesthetic of diffuser. Next, contrast imposed by layout and structure. Next, partitioning of space, volume, flow rate of air, maximum noise level, and last, length and type of screw required. Type of air diffuser. First, lower bladed. These are used to supply air at ceiling level. These curved bladers deflect air in 1, 2, 3 or 4 directions depending on where the diffuser is situated. Second, straight bladed. This big blade large format linear diffuser in design for high air volume application where low resistance in a requirement such as VAV system. Deliver effective one-way or two-way airflow distribution patterns made out of extruded aluminium section and variable in power coated or anodized finish. And third is linear slot. These are used for an alternative air distribution pattern and for aesthetic reasons. Air can be delivered around the perimeter of a room as opposite to point south interposed in a ceiling space. Linear slot can be used for return air as well as supply. Okay, for 3.12, ventilation design. Okay, the procedure below can be used to design ventilation system. First, calculate heat or cooling load, including sensible and latent heat. Next, calculate necessary Next, calculate the necessary air shift according the number of occupants and their activity or any other special process in the rooms. Next, calculate air supply temperature, calculate circulate mass of air, calculate temperature loss of ducts, calculate the outputs of components, heaters, coolers, washer, humidifier, calculate boiler or heat size, and last, design and calculate the duct system. Design concern. First, temperature, pressure, air contaminants, works practice, products protection, workers protection, building codes, equipment selection, energy selection, energy conservation, maintenance, security, expansion. How to design a ventilation system? Step 1. Decide which area of your home require ventilation. Typically, these are your roof space, your living space, and or your subfloor. Step 2. Determine the equipment you will need for ventilating your roof space, your living space, your subfloor. Step 3. Determine how many roof vents you will need. Step 4. Ensure there is adequate make-up air into the ventilated space. To optimize your ventilation system, you will need to create an inlet for fresh, cool outside air to replace the air that is removed from the space being ventilated.
For 3.13, resistances to airflow. Airflow, flow of air or any other fluid, is caused by a pressure differential between 2 points. Flow will originate from an area of high energy or pressure and proceed to areas of lower energy and pressure. Type of flow. First, flow of turbulent. Second, flow of laminar. Resistance to flow. There are three important observations that describe the benefit of using total pressure. First, only total pressure in ductwork always drop in the direction of flow. Second, the measurement of energy level in an air stream is uniquely represented by total pressure only. Third, the fan energy increases both static and dynamic pressure. Okay, for component pressure, due to physical item with non-pressure drop, such as hood, filter, lowers or dampers. Second, dynamic pressure. The dynamic losses are the result of change in direction and velocity of airflow. For frictional pressure, frictional loss in duct section result from air viscosity and momentum exchange among particles moving with different velocities. Thank you. That's all from us. See you next time.